Alright, in this video I'm going to show you how to use a Picoscope to measure voltage versus amperage on a fuel injector. On this 97 Jeep that I'm working on, they're very easy to get to. Before we get started, I wanted to point out just one thing. Notice how every one of the fuel injectors has one wire that's the exact same color. That is your power wire, and it's fed to every one of those fuel injectors. It's constant power. The other wire that's different color is our control wire from the computer, and that is where we're going to be back probing in. We'll be using a T-pin for this, and that's what we're going to measure our voltage on. And then amperage is the same everywhere in the circuit, so we can go on either one of these wires with our amp clamp to measure our amperage. Okay, so when we come back, we will be able to see our signal here. Okay, so now I've got everything hooked up. You can see we got our amp clamp and our gators on our fuel injector there. Okay, we're on our 20 amp mode of our amp clamp. On the Picoscope here, you can see that on channel A, I've selected just a ×1 probe for voltage, and we're on a plus or minus 100 volt scale. And then on our amperage, I've selected the 60 amp clamp 20 amp mode, and we are plus or minus 2 amps. Our time divisions right now are 1 millisecond, and we are now running and we're taking a live reading. Now, in order to get this to continually repeat on my screen, I've put on a repeat trigger down here on channel A, and so every time voltage goes above a certain amount right here, that's when we're seeing this on our screen. Okay, so there's a lot of different things we can see here. Let's start with the voltage. First of all, you notice we're at running voltage, which we could take a measurement real quick. Okay, we're at about 13.69 volts or so. And then you can see when the fuel injector is commanded on by the computer that we get this voltage drop, and this time from here to here is our commanded injector on time from the computer. And you could go ahead and take a measurement of that and see what the computer is doing there. I know it's jumping around. Let's pause it for a second. Okay, we're gonna go from there over to there. Okay, and right up at the top it tells us we're at 4.159 milliseconds. That is our injector on time from the computer. Now, you'll notice as soon as the fuel injector shuts off, the voltage kind of spikes up. Every time you shut off a coil, you get this voltage spike, but you can also see that it's not a perfect spike. It kind of gets clamped off. So there's a clamping diode in here to minimize that voltage spike. All right, now let's take a look at this amperage. You can see as soon as the fuel injector turns on, amperage starts to climb. Right, the coil's building up its energy, and then right here, this little dip, this is where the pintle of the fuel injector actually opens, and then it's held open, held open, held open, held open, then the fuel injector shuts off. But the fuel injector doesn't actually shut all the way until you see this little dip right here on our voltage signal. Okay, so if we took out our measurements and went from pintle opening to pintle closing, we could actually see what the actual on time of the fuel injector is. Okay, so even though we were being commanded for somewhere around 4 milliseconds, I don't remember the exact number, we're actually only open for 2.43 milliseconds. Okay, so this is a really good test to find out if your fuel injectors are operating properly, if you're not seeing this pintle opening, or if you're seeing it way too early or way too late. Okay, you can tell a lot about how well your fuel injectors are performing.